Hey, it's Marky Does Math. You may have seen videos on YouTube Shorts, Instagram Reels, or TikTok of people multiplying numbers using Japanese multiplication. You may have also heard it be called Chinese multiplication, line multiplication, and other ways too. I'll just refer to it as Japanese multiplication because that seems to be the most common name out there. In this video, I'll go over why it works. However, before I do that, let me show you how it works with an example if you forgot or have never seen it before. Let's say we're multiplying 12 by 22. For each number, we need to look at its place values. 12 has 1 in its tens place and 2 in its ones place, so we'll first draw one line for the 1 in the tens place and then draw two lines for the 2 in the ones place. These lines should be diagonal and going from the bottom left to the top right. Now let's look at 22. 22 has 2 in its tens place and 2 in its ones place, so we'll first draw two lines for the 2 in the tens place and then draw two lines for the 2 in the ones place. These lines will also be diagonal, but going from the top left to the bottom right. After drawing all the lines, we'll group the intersections on the right together, the intersections in the middle together, and the intersections on the left together by drawing ovals around them. In other words, we're grouping intersections vertically. From right to left, the number of intersections in each group represents the value of the associated place value, the ones, tens, or hundreds place. Therefore, the ones place must be 4, the tens place must be 6, and the hundreds place must be 2. We see that 12 times 22 is 264, which is indeed correct. Why did this work? Well, to see why, let's multiply 12 by 22 with the standard method, long multiplication. We'll have 12 on the top and 22 on the bottom. 2 times 2 is 4, 2 times 1 is 2, 2 times 2 is 4, and 2 times 1 is 2. This is where you want to think back to when we just used Japanese multiplication to also multiply 12 by 22. To get the value of the product's ones place, we need to bring down the 4, which corresponds to the number of intersections 4 on the right. To get the value of the product's tens place, we need to add 2 and 4 to get 6, which corresponds to the number of intersections 6 in the middle. To get the value of the product's hundreds place, we need to bring down the 2, which corresponds to the number of intersections 2 on the left. With long multiplication, we got 264 as the product as well. As we can see, Japanese multiplication is a visual way of representing long multiplication. You can use Japanese multiplication with whole numbers that have more than 2 digits and less than 2 digits as well. Let's say we have 14 being multiplied by 132. For 14, let's draw one line for the 1 in the tens place and 4 lines for the 4 in the ones place. For 132, let's draw one line for the 1 in the hundreds place, 3 lines for the 3 in the tens place, and 2 lines for the 2 in the ones place. Now, let's group the intersections vertically with ovals, and notice we have 4 groups this time. Remember, after the hundreds place, there is the thousands place, so going from right to left, the groups of intersections will represent the ones place, tens place, hundreds place, and thousands place. By counting the number of intersections in each group, we see that the ones place must be 8, the tens place must be 14. Wait a second, what do we do in this situation? Well, we just carry over the 1 that's in the tens place of 14 to the next group, which is exactly what we would do if we used the long multiplication. Thus, since there are 7 intersections in the next group, the hundreds place must be 7 plus 1, or 8. Lastly, the thousands place is 1. So the product of 14 times 132 must be 1,848. At the end of the video, there is an example of using Japanese multiplication with whole numbers that have 1 digit. Something I noticed that I haven't seen anywhere yet is that Japanese multiplication can also be used with decimals. We follow the same method we used with whole numbers, but there is an added step that we'll see in the next example. Let's say we have 3.2 times 2.1. For 3.2, we'll draw 3 lines for the 3 in the ones place and 2 lines for the 2 in the tenths place. For 2.1, we'll draw 2 lines for the 2 in the ones place and 1 line for the 1 in the tenths place. And we can now group the intersections vertically. Just like with long multiplication, count the number of decimal places in the factors. That sum will be the number of decimal places in the product. 3.2 and 2.1 have 2 decimal places together, so the product must have 2 decimal places. Therefore, the rightmost group of intersections will represent the hundredths place, The middle group of intersections will represent the tenths place, and the left group of intersections will represent the ones place. Of course, the decimal point will be in between the ones and tenths place. Lastly, we just count the number of intersections to see that the hundredths place is 2, the tenths place is 7, and the ones place is 6. Therefore, 3.2 times 2.1 is 6.72. Now, is there anything bad about Japanese multiplication? Well, if you end up having to deal with a lot of lines, then it's probably not useful. It'll take a long time to draw out each line and figure out the number of intersection points. For example, let's look at 9 times 7. While drawing 9 lines for 9 and 7 lines for 7, we begin to see how many intersection points there are. After counting, we see that there are 63 intersection points. Since there's only one group of intersections here, we don't need to worry about carrying over the 6 somewhere. We see that 9 times 7 is 63, but there are most definitely faster ways to finding the product than using Japanese multiplication. Thank you for watching this video, and let me know in the comments what you think of Japanese multiplication.